Hello, I'm Mr. McBrien. This is TEJ3M, Arduino 6, Motors and Functions. So yesterday we talked about inputs and what to do with signals that come into our pins on our Arduino. Today we're going to talk a little bit about functions. We've alluded to them before, but we'll talk a bit more about them today and talk about movement. So functions are going to be very important to our work today, and so it's a good idea for us to kind of approach them a little with a little more detail than we've done previously. So functions are modular code. They can be reused over and over again, and they can be used within a given sketch called over and over again to do various things. They're useful because they're somewhat customizable, and we'll see a little bit of that later. And they're useful because we don't have to include the same code, over and over and over again when we want to do the same kinds of things over and over again. We can write our own functions and call them as we need them. Today we're going to look at some functions that other people have created for us after we've done some simple definitions. Now, functions wouldn't be very useful if they had to be done the exact same way every time, if the code were used exactly the same each time we called them. Luckily, they can have custom inputs, so we can send them values for a given argument, and they can use those to make a custom set of code for a given situation. Okay, so this, I won't claim that I did this. This gorgeous graphic came from the Arduino reference on functions, but this gives us an anatomy of a given function. We have some code within curly brackets that includes what happens. It includes given values that will be returned. The variable gets declared in here for what is going to get returned. So we've got ourselves a set of code inside our function. We've got two arguments, two parameters that are passed to the function. And so when we call it, we have to send it these two values, x and y. It'll perform some operation on x and y and then return a result, in this case multiplying them together. So we can have practically any Arduino code within our function. By the way, sometimes functions have parameters, sometimes they don't. Sometimes they return a value, sometimes they don't. Notice the form that our function takes. Our given function, if it has nothing to return, by the way, then it will have this void at the front. Okay, so there's the basics of a function. You may have written some in that previous activity, you may not have. We're going to use those functions today. So before we do that though, let's talk about movement. A large number of interesting applications of the Arduino need motors. Maybe you've got an autonomous car you want to build. Maybe you want to build a drone. Maybe you just want to spin a fan. There's lots of possibilities. Huge numbers of applications with motors. Motors, have certain behaviors that make them different from other components. So they get their own. They get their own hardware, and they also get their own YouTube video. So what makes motors special then? First off is the thing we already know. They don't obey Ohm's law, and so we have to use pulse width modulation to modify the amount of power that goes to motors, and we've already talked about that before. They often require very high voltage. There's practically no such thing as a low voltage motor. they require high current to activate, and they have this thing called back EMF that we'll talk about in a few seconds. So we already know how to run a motor at 1/3 power. We know we use pulse width modulation for this. So that part of our equation is already taken care of for us. But those other three components, those other three attributes, we have no solution for that within the normal Arduino. So how do we cope with those? The answer is with our first ever shield. So you may remember that shields are hardware extensions for the Arduino. This is an inexpensive motor driver shield for our Arduino device. Now, why do we want to use one of these things? Well, the Arduino just is not good for handling large amounts of current. If you try to run any large amount of current through an Arduino, it will burn out. Arduinos are also limited to 5 volts of output, and motors need higher voltages than that. So the Ardumoto can manage 2 amps per channel, much more than an Arduino. It can also handle up to 18 volts input. It's worth noting that that this motor shield needs its own power supply. It can't run from the power from the Arduino. In case you're curious, SparkFun are not the only ones who make motor shields. There are lots of other motor shields, but they all work in roughly the same way, so we can use it as our example. So now we've got our current taken care of, we've got our voltage taken care of with our motor shield. We might as well have a quick discussion about this thing, back EMF. So, back EMF is a major concern when you go to control motors electronically. And the reason why is motors push back against the potential that we applied to them. When we remove the potential from a running motor, there is a potential pushed back by the moving motor, and the current reverses. And this will tend to burn out electronic components if we're not careful. So all circuits involving electronic control of motors should include what's called a flyback diode. And what this does is it dissipates the reverse current to avoid it burning out electronic components. Now the good news here is that all motor shields include these flyback diodes, so we don't have to worry about back EMF as long as we use these motor shields. So how do we control that crazy thing? Well, in fact, the folks at SparkFun have written functions for us to make it easier. It's really not that difficult if you don't use their functions, but their functions give us some very convenient commands. So they wrote our drive Ardumoto function for us that allows us to send 3 parameters to that function when we call it. So we call it specifying which motor we want to move, which direction we want it to move, and what the power level should be. So in this case, full power, half power. And they even wrote a separate function to stop the motor. So our stop command is its own function. Of course, you could have just written 0 output to those to that pin, but this is certainly clearer in terms of its implementation. So pulse width modulation, we already talked about this, but we have that capacity within there to have 256 different levels of power if we include maximum and 0. The limitations of the Ardumoto: 2 amps maximum output current, 8 volts maximum potential in. And of course, if we want to run 2 amps, we need to make sure that our power supply can support that. Okay, in terms of the pins, all of this is in the SparkFun documentation, so that's no big deal. Incidentally, if you want to work with the motor shield without running a pair of motors, if your motors are on back order, or if you just simply haven't got them wired up yet but you want to test your code, there are LED indicators on the shield that indicate the directions that the motors are being told to turn, so you can verify that your code is working without wiring up your motors. And this can be very handy early in your development. So there's a complete sketch available from SparkFun, which you can go ahead and modify as you need to. The references are there. And with this in place, you receive all of the functions to do the control of the motors. This should make it very easy to do our activities for today. So after you've downloaded the code then and review it and the comments, you can wire up 2 motors to the shield, go ahead and run the sketch and see what happens. Just have a look at it. Once you've done that, you can then start adapting the sketch to tell your robot to move around. It's usually convenient to put it up on blocks so the motors just spin rather than chasing it around the room. But you can go ahead and adapt the sketch and get your robot moving forward at full power for 1 second, which means both motors turning the same direction. Sometimes funny results happen after you've done wiring it up. You can design things for sharp right turns and gentle right turns, the same for left turns. If you want to, you can write your own functions for these things. So go ahead, and once you've designed this stuff, you can test your code by watching the motors spin. Okay, you can also adapt that code for activity 2, putting a braking segment between each of your movement sections. By the way, here is from their website the identification of the pins involved with the shield, and here you can see your LEDs for the 2 motors here. Okay, if you've made it through all those activities, you can also go ahead and use math. Take the radius of your wheel. Try to calculate how to make your robot go in a circle with diameter 40 centimeters. If you're not real good with math, you can always just simply do trial and error to do that. And you can go ahead and start controlling the robot itself. Make it run in a 40 centimeter circle for 10 seconds and then stop. Okay, out to the extension side now, you can start to get a feeling for how to control your robot. Try to make it move in a figure 8. All right, so hopefully you had fun with those activities. Let's go through what we learned today. Today we looked at our first functions as sets of code that can be called at any time in a sketch. We examined the ways that motors are different from other components, the ways that their behavior is unique. We talked about and defined back EMF and talked about why flyback diodes are so important if we're going to do electronic control of motors. And we examined how a motor controller can be used to drive 2 motors supporting reverse, pulse width modulation, and you had a look at how to control the movement of a robot based on relative speed of the wheels. So for your homework, go ahead and complete all those motor control activities, and you should be an expert by the end of that at controlling robots. So there are lots of references online for functions, and especially for the Ardumoto Shield. Go ahead and have a look at those and see if you can get all those sketches going. Hopefully you had fun today. Thanks very much. Have a great night.